Hi, my students, and welcome to another Math Homework Help by your teacher M. Hello, our topic for today is about measurements. We will go ahead and tackle about measurements in customary, such as measurements in length, like miles, yards, feet, inches, measurements in volume and capacity, like gallons, quarts, pints, cups and fluid ounces. Also in weight and mass. There are tons and pounds and ounces. Okay, and then we will also talk about units in metric system like kilometers, meters, centimeters, milliliters, millimeters, and so on. For example, we are trying to convert feet and inches. Therefore, we can create a table ratio for that, starting with what we know from our reference material chart, which is 1 foot is equivalent to 12 inches, and that is unit rate for foot and inches. So you start with the unit rate, 1 is to 12. Then from there, you can go ahead and add another foot here. That means you're going to have another 12 inches. That will make 24 inches now. So a ratio table can be helpful when we are working with smaller numbers. But what if we are given bigger numbers, such as, for example, 144 or something bigger? You cannot go ahead and create a longer table for this. Maybe you can, but it will take a lot of time. So to save time, we're going to go ahead and use a proportion. A proportion is comparing two ratios or two fractions. Okay? So you're going to have to look at your reference material guide and find out which one will be your first ratio. It depends on the problem whether they're talking about feet and inches or yards and feet or miles and yards, or maybe something from volume and capacity like gallons, quarts, pints, cups, and ounces. Okay, so let's have an example next. So for example, you are given 144 inches and they want you to convert this 144 inches into feet. So it's kind of a large number. So what we're going to do is use a proportion. So on your proportion, you will always have two fractions or two ratios to compare. So the equal sign is in the middle because it's saying that these two ratios should be equal to each other. So where do we begin? We're going to go ahead and look at inches and feet. So under the length in customary, that is 1 foot is 12 inches. So that's going to be your first fraction or ratio. 1 is to 12. This is your number of feet. And this is the number of inches. And you always have to label your numbers so you'll not get confused. So you already have the first ratio or fraction, which is from the table or reference material guide, 1 foot is to 12 inches. The given number is inches. So where are we going to place it? Of course, across the 12 because they're both number of inches. Okay, so the 144 should be here. Okay, and then at the top, we don't have the number of feet yet. So it's just an empty box, or in algebra, we put an X for a missing number. The first step in solving a proportion is you cross multiply the ones that are there that you can cross multiply. So it's not the 12 and the X. It should be the 144 times the 1. So we all know that 144 times 1 will still be 144. So that is step 1, cross multiply. Now step 2 is divide. So whatever you got from step 1, you put it inside a division box and then divide it with the other number we haven't used from our proportion. So which number we haven't used here is the 12. So that's going to be our divisor. And you know that 14 divided by 12 is 1. Then subtract down below. Therefore, 144 inches is equivalent to 12 feet. So let's look at a word problem. Mario is 6 feet and 3 inches tall. How tall is Mario in inches? So one of the numbers given is in feet, and the other part of Mario's height is 3 inches. So he is 6 feet and 3 inches tall. But we only need his height in inches. So what are we going to do is change that 6 feet into inches. So 6 feet. How many inches will this be? So what are we going to do? Set up our proportion. Place the given 6 feet across 1 because they're both number of feet. Then we don't know the inches, so an empty box here or an X to represent a missing number. Step 1 is cross multiply. Step 2 is divide what you got from step 1 by the other number we haven't used from the proportion, which is the 1. So how tall is Mario in just inches? Mario is not just 72 inches tall. Why? Because that's just the 6 feet. Remember, he is 6 feet tall and 3 inches as well. So what are we going to do with 72 and that extra 3 inches? We're going to have to add both inches. And now we're going to have Mario's height in inches, which is a total of 75 inches. Now, what about when we are prompted with comparing two measurements but with different units? So what are you going to do is to convert the other one to become the same as the other unit. So like this one, 8 feet compared with 3 yards. Which one is longer? So I will suggest that you change that 3 yards into feet. So in this proportion, I use the 3 yards because I want to go ahead and convert that into feet. Okay? And then once I got the number of feet, I will compare it with the 8 feet given here, and I'll be able to tell which one is longer or shorter. Now that we converted that 3 yards into feet, which is now 9 feet, we can say that 3 yards is longer than 8 feet because 3 yards is equivalent to 9 feet. Now let's look at weight and mass. The problem is asking us to convert 2.5 tons to pounds. Remember that I mentioned earlier that we can use a ratio table such as this. But let's go ahead and set up a proportion first and convert that 2.5 tons to pounds. And then we're going to go back and fill out this ratio table for tons and pounds. Cross multiply. There is 1 digit behind a decimal point, so on your final answer, you have to place 1 digit behind decimal point. Therefore, our answer is 5,000 pounds. That is equivalent to that 2.5 tons. Now let's make sense out of this, because in filling out the ratio table, we can make use of our common sense in math. So, for example, you already know that 1 ton is 2,000 pounds. Therefore, if you double the 1 ton, that's going to be 2 tons. Of course, you're going to be doubling the 2,000 pounds as well. Therefore, that's going to be 4,000 pounds. Now think of half of a ton, meaning it's not 1 whole ton, but it's just half, 0.5 or 1/2 ton. Will it still be 2,000 pounds? Of course not. It's gonna be half of that 2,000 because we don't want the whole ton, we just want half, or in fraction 1/2, half ton. Therefore, it's gonna be half of 2,000, which is 1,000 pounds. Okay, so half ton is just half of 2,000, which is 1,000 pounds. Does that make sense? Thus, if I have 1.5 or 1.5 tons, I will have that 2,000 and the half, which is 1,000. Therefore, 1.5 tons is 3,000 pounds. Now, we already know that 2 tons will equal to 4,000 pounds. Okay? Because 1 ton is 2,000, therefore double that. You're going to have double of 2,000, which is 4,000. Now, what about if we have 2.5? So you know you have 2 tons, which is 4,000, and that half. Remember, half of 2,000 is 1,000. So you're just adding 1,000 to your 4,000. Therefore, 2.5 tons or 2.5 tons is going to be a total of 5,000 pounds. Does it make sense? Now, 3 tons, of course, that's going to be 3 times of this, right? So 3 times 2,000, that's going to be 6,000. Will you be able to tell what will be 3.5 tons in pounds? Go ahead, think about it. So basically, we're just multiplying the number of tons by 2,000 each time we have 1 ton or more than 1 ton. Therefore, all we have to do is multiply that by 2,000 because each ton is 2,000 pounds. So 3 times 2,000, that's going to be 6,000 pounds. Then let's go ahead and multiply 3.5 tons times 2,000. How much will that be? So using common sense, you already know that 3 tons is 6,000 pounds plus the half of that 2,000, which is 1,000. So add that to your 6,000. That's going to be 7,000 here. Now let's go ahead and multiply 3.5 times 2,000. Are we really going to have 7,000 pounds? Let's go ahead and show our work on that one. And I always tell my students, make sure you're adding all the numbers in straight columns, okay? Because sometimes they write it at the wrong spot and they're writing it in slanted position. So there's a chance that they add the wrong numbers. How many numbers do we have behind a decimal point? There's just 1 digit. So on our final answer, we have to place 1 digit behind a decimal point. Isn't it our answer is 7,000 when we have 3.5 tons? You will have 7,000 pounds. 4 tons times 2,000 is going to be 8,000 pounds. Now 4 and 1/4 tons, that is also the same thing as 4.25. So the number you're going to multiply by your 2,000 can be that 4 and 1/4 or the decimal form of 4 and 1/4, which is 4.25. Now, how many numbers are there behind our decimal point? There are 2 digits behind the decimal point. Therefore, on our final answer, you should have 2 digits behind decimal point. Therefore, it's not 850,000, but it's 8,500 pounds. That will be equal to 4.25 tons or 4 and 1/4 tons. Now, what I want you to do is copy the rest of the table. You go ahead and find how much pounds is equivalent to each of the tons given here. Okay? All you have to do is multiply 5 times 2,000. Multiply the decimal form of 5 and 1/4, which is 5.25, by 2,000. Because each ton is 2,000 pounds. Therefore, whatever number of tons you have, you go ahead and multiply it by 2,000. Then you're going to have the number of pounds that you need that will be equivalent to that number of tons given. Okay? So good luck. Do it on your notebook. And don't forget to show your work and double check it. Therefore, 2 digits are behind our decimal point. Therefore, on your final answer, place 2 digits behind your decimal point. The number of pounds equivalent to 5.5 tons is 10,500 pounds. Now, let's make sense out of this. Isn't it that 5 tons is 10,000 pounds? Just like what we have here on the table. Okay. Now, what about the 1/4 tons? It's not 1/2 anymore. It's not half of 2,000. Therefore, we're just gonna get 1/4 of 2,000, or we're gonna have to divide 2,000 by 4 parts to get that 1/4 of 2,000. It's no longer gonna be 1,000. So 1/4 tons is equivalent to 500 pounds. That's why when we have 5 and 1/4 tons, all we have to do is add 10,000 pounds and the 500 pounds, which will give us 10,500 pounds. That is still equivalent to your 5 and 1/4 tons or 5.25 tons in decimal. So let's just say this is your whole ton, and then we have to show how many pounds it's equivalent to. So 1 ton, you're going to have 2,000 pounds. Now, if we divide 1 ton or 2,000 pounds in half, you know that each half will be 1,000 pounds. Now, what about if we further divide it into 4 parts? How much pounds will be each part here? So looking at our fraction bars for 1 ton, if I say I need half ton, so half is this one, which is half of the 2,000 pounds, right? So half ton is 1,000 pounds. So what about if I cut that 1 ton into 4 parts, right? So each is 1/4. This is a fourth. This is a fourth. Another fourth. Another fourth. So what is 1/4 of a ton? So look at the drawing. Look at the fraction bar. Isn't it 1/4 of a ton is 500 pounds? Now, does everything make sense now? Okay, so using fraction bars, common sense, using ratio tables, even setting up a proportion will help in converting within customary system. Good luck on your homework, and I'll see you in class. Bye!